Welcome everyone, my name is Tatiana and this is my video series on OTF Studio thin film software. OTF Studio is a very powerful, smart and extremely fast tool for multi-layer design, thin film characterization, reverse engineering and monitoring of optical coatings. In this video I continue with a topic we use every day, plots. If you missed the previous part, the link is in the description. As we have seen before, the axis settings can be configured through the sliding panel. You can also zoom in and zoom out plots to inspect any region in more detail. Reflectance, transmittance and absorption can be plotted in %, arbitrary units, dB attenuation or optical density. You can adjust these units in the OTF Studio configuration panel available through the settings ribbon. In practice, optical filter attenuation is typically expressed in optical density or in decibels. Let's move to scaling. The default scale is linear, which displays reflectance and transmittance values with uniform spacing across the axis. For reflectance and transmittance plots during filter design, a logarithmic scale is useful when you need to show regions of very small values of reflectance and transmittance in more detail. A diabatic scale provides a more detailed view of both high and low values of spectral characteristics, for example, in this narrow bandpass filter design. In many practical situations during filter design, it may be convenient to plot reflectance or transmittance not only in linear scale, but also simultaneously in optical density. In OTF Studio, it can be organized using the secondary vertical axis. View ribbon, I can create a secondary axis for this evaluation plot. And this axis appears on the right side. And now we have two identical transmittance curves because they both are in linear scale. But if I switch to the secondary axis panel here, I switch and here in optical density, I can check optical density and the second curve will be shown now in optical density. And also I can set the limits from 0 to 10. And this is very convenient for filter design, for narrow bandpass filters, for notch filters. And these curves will be shown also during synthesis. During notch filter designing, it also can be convenient to plot transmittance in optical density simultaneously with reflectance on the same plot. To do this, I can also open secondary axis, transmittance for this plot, for this evaluation plot, commit. Transmittance axis appears, but it's by default in linear scale. I can switch to second axis panel, activate optical density, and set limits for this second axis from 0 to 10 OD. So, and here I can see simultaneously transmittance, how it behaves at this central wavelength. How to remove the second axis? Again, view, second axis tab, remove the secondary axis. Check, commit, and axis disappears. The secondary axis feature enables you to construct a really compact and informative plots by combining various characteristics in a single view. This is an example of designing an immersed beam splitter from one of my previous videos. The link to this video is in the video description. Here in this design task, I wanted to maximize transmittance S polarization and minimize transmittance P polarization in the visible range. The important spectral characteristic was also the ratio between transmittance S and transmittance P cases. I have created this characteristic using expressions feature. Then I would like to add this characteristic on the plot using secondary axis. I create the secondary axis and choose this characteristic. This is the ratio, and I would like to monitor it at 65 degrees angle of incidence. Commit. Then this characteristic, this curve appears on the plot and the secondary axis appears on the plot. And to distinguish this ratio from transmittance, S and P polarization, I change the style from solid to dash using chart designer. This curve appears and I can monitor it during designing process. Start designing using gradient evolution, and very fast I can obtain a good solution. And we can see very high transmittance, close to 100%. Transmittance for P polarization is close to 0. And the ratio between these transmittance S and P polarizations is higher than 1000. That is very good result. The plotting tools are flexible. You can easily configure a plot where this ratio, transmittance S to transmittance P, is on the primary axis, and transmittance S and transmittance P on the secondary axis. On the sliding panel, you have two sub-panels for primary and secondary axis. You can switch between them and adjust the plots as you want. I hope this video was helpful, was useful. Many thanks for watching. If you have questions, you are welcome to contact me, and see you in the next video. Bye!